Question 10, Part A, Part 1. On the same set of axes, accurately draw the graphs of y equals sin x and y equals 2 over 3 times x for x greater than or equal to 0 and less than or equal to pi. Here is a graph of the line y equals 2 over 3 times x and the curve y equals sin x drawn on the same set of axes. Now horizontally, I used a scale of 90 millimeters is equal to 3 units on the x-axis. And vertically, I used 2 lines on the page to equal 1 unit in the vertical direction. Now the line y equals 2 over 3 times x is a line that starts from the origin and passes through the point 3, 2. Now the curve y equals sin x starts at the origin and is also 0 at the point where x is equal to pi. Now sin x is equal to 1 when x is equal to pi over 2, and I've marked that with a point there. Now sin x is equal to 0.5 or half when x is equal to pi over 6, so that's this point here, and also when x is equal to 5 pi over 6. Part 2. Find the gradient of the tangent to y equals sin x at the origin. Let f of x equal sin x. Differentiating f of x with respect to x, we get f dash of x is equal to cos x. Now at the origin, the x coordinate of the origin is 0. So at x equals 0, the value of f dash of x, so f dash of 0, is equal to cos of 0, which equals 1. Therefore, the gradient of the tangent to y equals sin x at the origin is 1. Part 3. For what values of m does the equation sin x equals mx have a solution in the domain x greater than 0 and less than pi? The equation sin x equals mx will have a solution if the line y equals mx intersects with the curve y equals sin x in the domain x greater than 0 and less than pi. So we're not including the endpoints of the curve y equals sin x when x is equal to 0 and x is equal to pi. Consider the graph that we sketched in part 1. And in particular, consider the line that we sketched, y equals 2 over 3 times x. Now there's clearly a point of intersection somewhere between x equals 0 and x equals pi. So somewhere here. So consider the gradient of the line y equals mx. Now if m is 0, that's a horizontal line starting from the origin. So in other words, it's a line that's superimposed on the x-axis. So nowhere in the domain x greater than 0 and less than pi will that line intersect with y equals sin x. So m has to be greater than 0. In other words, it has to have some positive gradient. Now from part 2, we found that the gradient of the tangent to y equals sin x at the origin is 1. So going back to our curve, so at the origin, if we were to sketch a tangent to the curve y equals sin x, we find that it only intersects with the curve y equals sin x at the origin itself, but that's not included in the domain. X has to be greater than 0. So m also has to be less than 1. So putting that together, from part 1 and part 2, the line y equals mx intersects with y equals sin x for x greater than 0 and less than pi when the value of m is greater than 0 and less than 1. Hence the equation sin x equals mx has a solution when m is greater than 0 and m is less than 1.